Very much for the invitation and the introduction. I'm Gergely Sipos, working for the EGI Foundation, which is the coordinating institute of the EGI Federation. And my role there is to engage with scientific communities, projects, research infrastructures and other structures to teach them, train them, inform them about what EGI is, what we offer, and how can we provide computing and storage and data services for their work. In this short overview, I will give a very brief introduction to EGI, including what we are, what we do, what is the infrastructure we offer, who are we, where can you find us, and then I will talk about the services that we offer and that we can provide for communities. I will detail a bit about how to access these capacities, what are the processes around that, and I will inform you through a few examples that I picked, which I thought would be relevant for this project. At the end, I would like to close with some introduction to the European Open Science Cloud, which is the EOSC acronym here, and just very practical next steps. So EGI was established in 2010 after nearly 1 decade of EU-funded or co-funded projects that first set up a computing infrastructure for the Large Hadron experiment at CERN, but then it was generalized and opened up for other scientific disciplines. And then in 2010 they set up an institute in Amsterdam, the EGI Foundation, which is the coordinator and promoter of this whole infrastructure, which is open for any domain of science, any discipline. And it is based on a federated approach, connecting and making accessible resources offered by national, typically academic providers, universities, and the research centers. And this is a snapshot of where the partners are of EGI. These are the partners who provide resources, and a resource here is typically indicating a cluster resource with a few hundred or up to, let's say, 1,000 CPU cores with storage, which can be online storage disk, or it can be an offline storage tape, which is more for archival purposes. There is a growing number of centers which offer cloud capacity. So traditionally there was the HTC providers, currently more than 300, which are more suitable for batch computing jobs. But there is a growing number of cloud providers which are very similar services actually than Amazon Web Services, for example. We are serving researchers all around the globe, and as I said, EGI Foundation is the coordinating entity. Those of you who know how research infrastructures operate, they have typically an S3 coordinating institute. Here, EGI Foundation fulfills a very similar role. But legally, it's a foundation, not an ERIC. This whole federation was established through members, which represents national entities, national computing facilities. Currently, we have 22 national members, call them NGIs, plus 2 European intergovernmental research organizations that also have full membership, CERN and EMBL, EBI, that's the molecular bioinformatics laboratory. And hopefully, in the near future, we will expand the membership towards ERICs, which are the coordinators of science discipline-specific research infrastructures. But we are, on this previous slide, you may have noticed that these are all European institutes, but we have partnerships outside of Europe, and we are collaborating with large similar initiatives almost on every globe, on every continent, to build a globally federated infrastructure and in order to broker services to large communities. And here is a snapshot actually of the website, which is very much, if you go to the EGI.eu website, it's very clean. It has the main page, which is the services, what do we offer. And currently we have something like 15 services. Not all of them are in the public catalog, which is on this screenshot. I think those are, I don't know, 10 or so, 12. And these services are split into three categories. First, compute services, storage and data second, and training the third. The high throughput compute under the compute services was the traditional one that was heavily used and still heavily used by the high energy physics community for the batch execution of jobs that are typically parameter sweep applications, so independent jobs can run on different clusters anywhere basically, and then the results are gathered back and analyzed and then post-processed. There is an increasing demand and increasing capacity under the cloud computing facilities, so these are still typically clusters which are offered through OpenStack or OpenNebula or other open source cloud computing middleware solutions. There is an increasing demand for container computing, and we offer possibility for container execution inside the cloud basically. In the data and storage space, you have the online storage, which is typically a kind of scratch base that you can use for a week or for a month to store the data that serves as input and output of your calculation. But we also offer archive storage that can be maintained for the longer term. Plus, we offer data transfer services, which are very much needed for the large-scale calculations. Under the training section, you can see we offer FITSM training, which is more for facility managers or operators of IT services. So actually, maybe the MS4 OSC project would be one of them who will become an e-infrastructure provider. And then through the FITSM training, they can learn the best practices and a very practical and pragmatic approach to manage IT services. And we offer a training infrastructure, which is open for any science discipline who wants to run even domain-specific software training. And this training infrastructure is also a cloud-based infrastructure, so you can, as a trainer, for example, put any kind of software in advance of the training there, and then the users or the students interact with your software, not with the cloud itself directly. And we are expanding this portfolio. So in the pipeline of development, there are other services which are not visible publicly on the website, but are open for early adopters already. And there is a new category of security, where we offer recently security systems or services to facilitate access of distributed communities to online services. And here the question is, how can you manage user credentials? How can you identify the user attributes, user roles in a consistent manner across countries, across institutes, in order to map, for example, project managers consistently across the multiple servers? We have new services under the storage and data facilities or subject area. Here we are moving into a service domain where we can offer scalable access to reference data sets. We can make reference data sets, for example, offered as a service on any computing resource which is supporting a community. We can set up a content distribution service for replicating data sets on a regular manner, for example, for endpoints. And we can facilitate the federation of data for communities where the data is generated on multiple locations but need to be brought together even logically in order to do a calculation which needs to integrate input from all sorts of sources. And the last new category which is coming are operational tools, which again more relevant to large communities which want to operate their distributed and federated services for a large number of users. And here we are offering a configuration database, which is more or less an information system or yellow pages of the services that are available for a given community, or a monitoring system and backbone through which a community can set up domain-specific or service-specific test probes in order to check the availability and reliability of its own services and to present that information to their users. This service catalog is there to serve different forms of customers or users. But roughly speaking, we are engaged with 4 types of customers or users. The largest one in terms of the size of individual groups is the research infrastructures from the S3 roadmap. So those of you who know, the S3 roadmap is the booklet which is issued by the European Commission to recognize the largest science discipline facilities, research infrastructure facilities around Europe. The last issue of this roadmap came out in 2016, includes something like 50 of these S3 infrastructures. WLCG, the Large Hadron Collider at CERN, is one of those, but there are many others with whom we are engaged with, and some of them are already active users, some are just in the testing pipeline to assess the services. The second group are the kind of few-year long projects. Very often these are the virtual research environment projects co-funded by European Commission. For example, the second one is Open Dream Kit. I don't know how many of you know that. That's an H2020 project also dealing with software for mathematics. So that's if you don't know it, I see that a very strong partner for this project here. But there are many others. Then there are individual institutes, both from industry or sometimes academics, and then there is the long tail of science, which is the small individual groups or departments. We have a plethora of those. And how these different stakeholders can access the services. The access to EGI capacity happens through so-called virtual organizations, and a virtual organization is just a resource pool, an allocation of certain providers in order to support a given project or a given scientific goal. We have currently more than 200 of these groups or resource pools, virtual organizations on the infrastructure. Some are specialized to a given science discipline, others are specialized for a given project, yet others are specialized on a given geographical location. So they, for example, support any researcher that are active in Hungary or Central Europe. There are some allocations specifically for test purposes or incubation of new user communities. For example, the Fed Cloud at EGI.eu, that's a test virtual organization to try out the cloud facilities in EGI. So maybe that would be a reasonable starting point for this project as well, to assess the cloud services. And there is a training allocation that's open for running training courses. And here I included for you the link which you can browse to find a suitable video of the existing ones. But of course there is possibility to set up a new VO if you don't find anything matching your needs. And here I just graphically present you what's the main steps here. So in this setup, EGI or EGI Foundation more properly acts as a negotiator or a broker for you to find the most suitable resources from these 300 providers based on the requirements that you pose as a project or as a community. And typically these requirements start from, okay, I would like cloud services in this and these countries, or this and this virtual machine image sizes, amount of storage I need, the type of storage, whether it's object storage or block storage, what would be an acceptable availability percentage, what would be the cost, can I pay or is it free? Most of them are for free, by the way, for non-for-profit research. Okay. And then we compare that with the conditions and possibilities that we have from the network, and we select the most suitable providers for that given use case. And with those providers, we sign so-called operational level agreement, one document with each provider, and the summary of these operational level agreements ends up towards the community representative as a service level agreement. These are not legally binding documents. These are just an agreement of what you use from EGI and what EGI offers. Okay. We have so far, I think, around 15 communities that have such a document-based access to EGI. The other 180 or so are still from the previous period where we still didn't sign this. But this is working very well since we introduced this concept a year ago, because this gives us a framework to also capture satisfaction on a periodic basis from the user. That helps us improve the services, identify the most performing and best providers, and also we are able to generate performance reports and then inform the user community about what they actually used, what was available for them based on the SLA we signed. And what these user communities do is typically they build up their own ecosystem on top of these low-level cloud and HTC and storage services. And some of these domain-specific ecosystem services are also visible on the EGI website. On the website there is a thematic services tab, and there you can browse some of these. But I included a couple of examples here on the next slides. One, for example, from the VNMR community, that's about structural biology. They use the high throughput computing, so the grid computing setup. They use it in at least a dozen countries with access to a lot of computing power. They have very compute-intensive models to calculate the structure of biological entities. The second example, which I want to detail a bit, is about a federated cloud and the cloud service that we offer. And this is through the Chipster, which is a bioinformatics toolset that includes more than 300 analysis tools or models in it. And it is developed at the CSC Institute in Finland. And what we did with them is that we created a virtual organization, a resource pool out of the cloud providers we have. And this resource pool can be seen on the right side. There are 4 clouds shown on this diagram. And as part of this cloud offering, we have a so-called virtual appliances marketplace. That's a central catalog where a community, after they set up their own virtual organization, will have a space. And in this space, they can create a registry of those software tools that they want to share with their communities and with their users. Here, the Chipster is a relatively simple use case in that sense, because they have only one virtual machine image, which is relevant for the community. That virtual machine image includes all the 300 analysis tools. But maybe other communities have a dozen or even more virtual machine images, each encapsulating just a well-defined algorithm. And what this application marketplace is capable of is that once a virtual machine image is registered and endorsed by the community, then it replicates the image onto every cloud which is supporting that given community. And from that moment, there is a homogeneous view towards the users, because they can go to any cloud and they will find the same software pre-configured, ready to use. And how this community is using this is through a central web portal through which bioinformaticians can get access to this. And in the backend, this portal is capable to instantiate this Chipster toolset for the given user, let's say on the nearest cloud or on the national resource, which is the most suitable for the user, attach some block storage to store the input and output data, and then for the next user maybe in another cloud. So this provides a scalable architecture which is made kind of homogeneous towards the users and towards the developers of higher level tools such as the Chipster portal. Plus it offers this marketplace feature through this appliance marketplace where developers can share their applications and push it into the community space. And the last example I would like to show you is a more complex one. This is under development or finalization, and it combines different services from EGI, not just the cloud, or not just HTC. It is a combination of using the operational tools, the security tools, and the cloud tools. And this is aiming for a setup for the Elixir, which is one of the biggest, if not the biggest, research infrastructure in the life science domain. And Elixir is using the EGI tools to build their own infrastructure that federates the cloud systems from the life science research infrastructures that are in their network of national nodes. To do that, they need to use the EGI operations tools, the service catalog, the service registry, and the monitoring system. And they need to use the EGI check-in system in order to map their domain-specific user accounts that are issued by these life science institutes and to map those accounts consistently onto the cloud resources that are available for them. And this was already achieved. This infrastructure is operational, and that enables the users, on one hand, to register new cloud resources with their life science identity into this federation. It enables developers, application developers from that community to create new appliances and to share them with the users. And right now we are working on 5 demonstrator applications from different countries and different sub-disciplines under life sciences in order to make this system really useful for the life science community. And let me close this part with just a snapshot of the website. So I said that the first menu item is about EGI services. So this is almost exactly the same snapshot that I showed earlier. And here, basically, you can request kind of access or more information about any of these services, and you can read a bit more about the access policies. But what I said is basically, it very much depends on your requirements, what you want to access, and what are the resource providers that are matching your priorities and your purposes, your science discipline. And let me close the talk with a brief outview into the future. And the future will be this European Open Science Cloud, which is a recently started initiative from the European Commission. The first project that relates to establishing this European Open Science Cloud just started in January. That project is called the EOSC Pilot. And that one of its main goals is to define the governance of the European Open Science Cloud. And obviously that means that it needs to define what the European Open Science Cloud is. Otherwise it's difficult to define who will govern it. But the idea here is that to create a common hub or space where European research results can be sustained, can be shared, and can be made available under the so-called FAIR principles, which is findable, identifiable, accessible, and reusable. That's true both for data and for computational tools, applications, software, environments that facilitates research. So the EOSC pilot project will define the first kind of cornerstones of this, but there will be future calls and future projects to do that. And the next big one, which is currently under evaluation, was submitted at the end of March. And in that one, EGI is also involved. It's one of the main players there. And this project, if funded, we very much hope for that, it will be called EOSC Hub. And that will be establishing the whole backbone of this European Open Science Cloud. So what will be the baseline conditions to join and to use the cloud? What will be the first set of services that are offered in the cloud? This will be very much based on the service portfolio I just showed you, but it will be complemented with more services from the EUDATS e-infrastructure, which is another European infrastructure initiative, and with technologies from the Indigo Data Cloud, which is a cloud software development project currently ongoing. Plus, already in this EOSC Hub, there are many research infrastructures already on board, which will integrate domain-specific services into this European Open Science Cloud. So I would like to close this talk with that information. Yeah, and by the way, just one thing I forgot to mention, it's on the slide, that this EOSC pilot project has a call for demonstrators every 6 months. And I would like to point that out. That's an opportunity to get a bit of funding, but also to get recognition and to test, to try to integrate domain-specific applications with this future European Open Science Cloud, and through those demonstrations to influence what this European Open Science Cloud should be, what it should provide, how it should be accessible, and so on and so forth. The last call was closed at the end of April. So then roughly 5 months to go until the next call. Thank you.
Thank you very much.